Okay, let's keep going here in 1.8, other types of inequalities. Most of what we're going to do in this video is some calculator work. If you're watching this video at home, if you missed class or anything, don't worry so much about pushing the buttons on the calculators. You can still follow along and get a good idea what's going on here. And especially make sure to pay attention to example 4, I believe it is. That's a good part of what we're covering today. Let's see here. So example 3. First it says solve this polynomial inequality. And this one we don't really need the calculator to do. But let's just go through it old school. Of course we want to get 0 on the right side. So that'll be 4x squared minus 5x. And we'll subtract 6 from both sides. And now it's greater than 0. And this, we can factor that on the TI-89 with the F2, that drop-down algebra menu. But on this one, let me just hand you the correct factorizations. You can get this by a little trial and error. The factorization of the 4x squared is going to be 1x and 4x to give us our 4x squared. And then the factorization of negative 6 will be a minus 2 and a plus 3. So there's our factorization, and now, of course, we want to set each of these separately equal to 0 to get our key numbers. If x minus 2 is equal to 0, then x is 2. And for this one, if 4x plus 3 is equal to 0, then we're going to subtract 3 from each side. So that'll be a minus 3 over here. And then we'll divide through by 4, negative 3/4. So those are the key numbers. Again, those are going to chop up our number line into intervals that will either find our part of our solution set or not. So let's see, we're going to come up with some intervals. We're going to go all the way from negative infinity to the lowest of the key numbers, the negative 3/4. And our next interval will pick up there at negative 3/4 and go to the next key number 2. And then we're going to go from that key number 2 off to infinity. So remember, we're going to pick some test numbers. We're going to plug them in, and we're going to come up with our conclusion, either positive or negative. So let's see. The first test interval, negative infinity to negative 3/4. And why not negative 1? That'll be easy to deal with. And the easy way to check this, I'm going to underline it here in blue, is to plug that test number in here and see what comes out. So if we plug in negative 1 for x, negative 1 minus 2 is a negative, times 4 times negative 1 is negative 4, plus 3 is negative. Negative times negative is positive. So our conclusion is that is part of the solution. Okay, next interval. Negative 3/4 to positive. Whenever you go from negative to positive, a great test number is 0. If I plug 0 into the part underlined in blue here, 0 minus 2 is negative. Times 4 times 0 is 0, plus 3 is positive. Positive times negative is equal to a negative, and it is not part of the solution, because a negative number is not greater than 0. Last interval, from 2 to infinity, and why not just pick 3? If I plug 3 in here, 3 minus 2 is a positive 1. Times 4 times 3 is 12, plus 3 more is a big positive number. Positive times positive is positive. Is a positive number greater than 0? Yes, it is, and that is part of our solution. So we can draw a little number line now. Why not? And let's see our first key number, negative 3/4. And then we had another one at 2. And we found our inequality was strictly greater than, so these will be parentheses. And from negative infinity to negative 3/4 was part of it. So we have a parenthesis there at negative 3/4, and we're off to the left. And then we had everything from 2 to infinity was also part of the solution. Parenthesis at 2, off to infinity. So there is our one-dimensional, line graph of the solutions for this inequality. What about a graphical solution? If you were in class, we would get out the TI-89s and we would go to the Y editor. That would be the green diamond key F1, and that would take you to the Y editor. and we would plug in, we're looking at this polynomial, greater than 0. There is no inequalities in the y editor, so we just plug it in there as equal to. We'd plug in 4x squared would be the up caret key 2 minus 5 times x minus 6. And you would graph that. And you'd hit the green diamond, I think it's F3 key, and you'd get the graphing window to pop up. And you'd have something like this. You would see your XY axes here. I'll overlay them in black. And then the parabola would come in. And the parabola would cross here at -3/4, and it would dip under, and then it would cross here at 2. And, there is our number line from the previous part. From -3/4 to 2, we had our arrows going to the left and to the right. So here's -3/4. Back this up. Here at -3/4, we were off this way. And at +2, we were off this way. And remember, because the inequality was greater than or equal to 0, the solutions were the parts that were above the x-axis. Because we want to be greater than 0 on the y-axis. Well, here's the y-axis. We're greater than 0. Here on the parabola, let me just highlight this in blue, as we head off this way. And then to the left, as we go from -3/4 smaller, our parabola is back above the x-axis. So that is part of our solution set. Where we went below the x-axis was where we were not greater than 0. That's where we were less than 0. We were under the x-axis, so the inequality, that was not part of our solution set. And we've been doing this all along here. You may find it easier to determine the sign of a polynomial from its factored form. For instance, in that example, the test value 1 is substituted into the factor form. You can see the pattern, positive times negative. And that's something we've been doing for a while in this class, so I just thought I'd throw that in there to reinforce it. That is a nice little way to work on that. When solving a polynomial inequality, be sure you've accounted for the particular type of inequality symbol given in the inequality. For example, in example 3, note that the original inequality contained a greater than symbol, and the solution consisted of 2 open intervals. If the original equality had been this, with greater than or equal to, the solution set would have consisted of these intervals. Each of the polynomial inequalities in those first 3 examples has a solution set that consists of a single interval or the union of just 2 intervals. When solving the exercises for this section, watch for unusual solution sets, like you're about to see here in example 4. And remember, this is a more graphical interpretation of stuff, so we'll talk about it, and then the graph is really what I think brings it home. Let's see the first one here. X squared plus 2x plus 4 is greater than 0. If you try to factor that, that would be x and x. What are the factors of 4 that add up to 2? You're never going to get that to work, no matter how hard you try. And what's going on is this. The solution set for this inequality consists of the entire real number line, all the way from negative to positive infinity. In other words, the value of this quadratic is positive for any value of x. Let's see here, we're plugging in some number x and we're squaring it. And then we're going to multiply it by 2 and then add more to it. Even if we plug in negative numbers, when we square it here, that will be positive. And then we're going to do 2 times that negative number. That might be a negative, but it's going to be tiny. And we're going to add 4 more. So this is always actually going to be greater than 0. This could never turn out to be negative. And remember, it was a while ago, but when we talked about functions like this, graphically, how many solutions are there to this quadratic? There's none. It's a squared x squared, so it's going to be an upward opening parabola. And all this is happening is we're not going to cross the x-axis at all. What we've been doing up until now is we're crossing the x-axis, so we have positive and negative pieces. That determines what our solution set's going to be based on the inequality. Well, if we don't cross the x-axis at all, there are no solutions. So that's what's going on here. All real numbers would be our domain. All real numbers. Or, if you want to write it in this notation, from negative infinity to positive infinity. That would be our solution set. All real numbers, because we're always positive. We're always greater than 0. Okay, letter B. X squared plus 2x plus 1. This one we can factor. If we look at this to factor that, the factors of x squared are x and x. The factors of 1 that add up to 2, well, that would be a plus 1 and a plus 1. Now look at that, we got a repeater. We could look at it as set each of these equal to 0, and you'll get x equals negative 1 and x equals negative 1. So we do have an answer. We have two answers, but it's repeated. Or you could look at it as, you're just going to combine those into x plus 1 quantity squared less than or equal to 0. You could square root both sides and then just set that equal to 0 and get the same answer. X is negative 1. So how many solutions are there? When is this greater than, or I mean less than or equal to 0? Well, we're squaring it, and no matter what you square, it's always positive, so it's never going to be less than 0. But where would this equal 0? And we've already figured out, okay, that's when that in the parentheses is equal to 0, or at x is negative 1. What does that mean graphically? How many times letter A, how many times did that cross the x-axis? None. Oops. We have seen other ones, we've done quite a few, where we cross the x-axis at 2 points. 2 points if we have two factors, no points if our parabola exists entirely above the x-axis. Here we are going to not cross, but we're going to touch it at exactly 1 point. We're just going to touch the x-axis and bounce right off of it. And let's see what they have in here for this verbally. The solution set to this following inequality consists of a single real number, just negative 1, because this quadratic has only one key number at negative 1. And it's the only value that will satisfy the inequality. Again, here's our xy axis. We just have, here's our point negative 1. We're just going to touch. We're going to have our parabola opening up. Just skims the x-axis there. That's our only solution that would make this equal to 0. Again, it's never going to be less than 0, but it can equal 0. On to letter C. X squared plus 3x plus 5. Can we factor it? X and x. Factors of 5 add up to 3. That's not going to work. And this time it is less than 0. If there are no solutions to that, if we can't factor that down, and this is even more obvious than an earlier one, because, no, I guess we could have a little bit of a negative number here, but still it's going to be overpowered by the x squared and the positive 5. This one is also going to have no solutions, or I mean no x-intercepts. It is an x squared, parabola opening up. Is it going to cross the x-axis? No, it's not. The key here is, this time the inequality is less than 0. In letter A, if you look back up to that one, it was greater than 0, and that answer was all real numbers, because we were looking for it above 0, and our parabola was up here above the x-axis. Now we're saying, where is this negative? Is this parabola here ever in negative y territory? No. So here there are no solutions at all. Because that will never attain negative values. We're a parabola opening up, and we're above the x-axis the whole time. Okay, now here's another one. It's sort of a twist on an earlier one. Can we factor that? Let's check it out. Factorization of x squared is x and x. Factors of 4 that add up to negative 4, well, that's going to be a minus 2 and a minus 2. So this is looking a lot like something we did earlier. Both of these will give us the same key number. X minus 2 equals 0 means x equals 2. So here is our x value of 2. We are sure that this is an x squared. It is a parabola opening up. And this says greater than 0. So now that's the key here. In the earlier one, back up to letter B, if you look up in your notes, it was less than or equal to 0. So this, we want to know, when is it greater than 0, but not equal to 0? So think about that for a minute. Again, in B, it was less than or equal to 0. And we touched at one point. We were never down here. but we were equal to 0 at the point we touched. Now we want to know where it's greater than 0. Well, it's greater than 0 all over here, and it's greater than 0 all over here. In fact, there's only one spot where it's not greater than 0, and that's the spot where it's exactly equal to 0. So for this, what is the domain of this? Well, it's going to be a couple intervals. From negative infinity up to 2, and then from 2 off to positive infinity. But what do I want here? Do I have brackets or parentheses? Because 2 is not part of the solution, of course, we would have parentheses. If we wanted to, we could squeeze the old union symbol in there. So this is a more complicated way of saying all numbers except 2. I prefer myself set builder notation, the set of all x, such that x does not equal 2. Every other number is fine. 2 is the only one that will not make this true. Ooh, and I forgot over here we do something that the book has printed in there. The solution set of the following inequality consists of all real numbers except x equals 2. In interval notation, the solution set can be written as blah, blah, blah. We already talked about that. All right, so keep your eyes out for those where the unusual solution sets, where there might be no answer or just one number or every other number out there except, this one. All right, now time for a little bit of calculator stuff. Again, if you don't have a calculator at home, you're watching this video because you missed class, don't worry so much about this stuff. In the following exercises, whoa. There we go. In the following exercises, use a graphing utility to graph the equation. Use the graph to approximate the value of x that satisfies each equation. Okay, so again, in class we would go to the Y editor, green diamond F1, and we would type in this equation. And you're going to get something that sort of looks like this. Just for the general shape, this is a negative x squared. If it's negative x squared, it's definitely a parabola opening down. And we have x-intercept here of 3, another x-intercept at -1. And it kind of looks like, yeah, we cross the y-axis at 3. So we sort of look like this. Oh, that's a terrible parabola. Please forgive me. So this is what you would get on your graphing calculator's window, and use the graph to approximate the values of x that satisfy the equation, the inequality. The first one's easy. This is what we've been doing in class. Where is y less than 0? Or where do we cross the x-axis and head into negative territory on the y-axis? Well, that would be right here at -1 and all numbers to the left. And that would also be here at +3 and all numbers to the right. Now, here's a little twist that really helps because we have the calculator. What about if we set that to y is greater than 3? So what we want to do is figure out, okay, yeah, this is a terrible parabola. This crosses the 3. I should go up a little higher right here. So let me do something like that. That's terrible. I apologize. Let me get a little bit of this out of here. So now it says, use the calculator to estimate, and we're just getting an estimate here. Where are the y values greater than 3? So what we're sort of doing is moving up here. 1, 2, 3. Now we're at this 3. And we want to figure out where we are sort of down here on the x-axis. Let's see. Well, if you use the trace feature, if you look up, I got my TI-89 right here. Bring up a graph. And my batteries are dead on my TI-89 at home. Again, just look for the trace feature, and then you can use the little arrow keys. You got like the up arrow, down, right, and left. And you'll get a little blinker here on your right on the graph. Down in the left corner of your display is your x-coordinate, xc. In the lower right is your y-coordinate. What we want to do is get that y-coordinate right around 3. So use those left and right arrow buttons. You can move that blinker up and down the curve. Try to get it pretty close to a y value of 3. And see what your x-coordinate is. When you get over here, you'll see that's just about right on the y-axis. So when you get 3 on your y-coordinate there, you'll get a x-coordinate of about 0. And then you use your arrow keys again. You go up over the peak of the parabola, start to come down the other side, and you'll get again pretty close back to a positive 3 on the y-coordinate. And if you look over to your x-coordinate, that time you'll be getting pretty close to 2. So you come down here, that's about 2. This was right about 0. Again, it does say to approximate, so using that trace feature is good enough on these type of problems. Okay, this next one is really calculator required on this one. So again, we got this polynomial equation there, half x squared minus 2x plus 1. If you solve that, if you go to the solve feature, we can figure out the zeros of the function, or we could probably just find those graphically. So what you could do, that'd be the easier way. Just type this into the Y editor. Again, green diamond F1. Type this in exactly as you see it, and we're going to get the graph to pop out. And if we use the trace feature, what we could do is find the 0 feature. We're going to have our graph cross at 0.58, and then again over here, let me go that a little bit more to the left. This is 3.4. So those are the spots we cross the x-axis. And you'll see the graph is going to look something like this. Pretty steep. We cross here. We come down, dip below the x-axis a little bit, bounce back up, and we continue up. Remember, in essence, it's a positive squared, so it is a parabola opening up. And it does say, well, I sort of gave away this answer already, where on that is y greater than 0. Okay, we found where we are equal to 0. That's at 0.58 and 3.4. So we're interested in the parts of the parabola that are less than 0. So that's going to be all this down here, or just on the x-axis, the numbers in between 0.58 and 3.4. So just on our number line, we'd have these, and because of the or equal to, there would be brackets there. Where are we less than 0? Again, all this place under here. The next one is where on the function is the y values greater than 7. Well, if I just come along here and put a 7, we're going to have 2 of them. We're going to have one of them about here and the other one over here. So this is where we go back and use that trace feature, and you use your left and right arrows, and you'll get your blinking dot. Let me do like a little bullseye here. This will be blinking on your display, and you can use those arrow keys to slide it up and down the graph. Look down in the lower left coordinate or the lower right for your y-coordinate, and we'll find out what x-coordinate is there with it. So we'll slide that up until we see our y-coordinate hit about 7. And when you do that over here on the left, your x-coordinate is going to be about -2. And then you take your little blinker and you move it over here, down through the gully, up the other side. Get it right up about there when your y-coordinate is about 7 again. And you're going to see on your x-axis that happens at about 6. So this, it's easy to get from the graphing. To actually pull another number off of, besides the x-axis, these calculators are a pretty handy tool. Okay, we've done a couple parabolas. Let's move on to a third power one. Ooh, this is going to get a little... Actually, this one isn't too bad, even though it looks like we have some fractions in there. It's not bad. We could probably do this one without a calculator, but they're telling us to use one, so hey, what the heck. Here we go. And if you graph a cubic, a third power function, if it's a positive cubic, in general, you'll be going up to the right and down to the left. These other numbers around it will put a little twist and kink somewhere in the middle. Because these both have x's in it, I do know I will be going through the origin, that's for sure. And we could factor this, like I said before, and set those factors equal to 0. We are going to get one of them at -2. And another one at +2. Oop, that doesn't look very proportional there. Move that out there just a little bit. So if we do get this into the TI-89 and graph it, we are going to be down here, and we're going to head up, cross at the origin, dip back down, cross it 2 again, and then we're off toward infinity. So you got your graph. You can use the trace feature. Where is the graph greater than or equal to 0? So we're looking for the spots where above the x-axis. And that's greater than or equal to, so we can use brackets. That's going to start at -2, and then we're up above. So we keep doing that until we get to the origin, and then that little segment's going to end. And then we dip under the x-axis down here into -y territory, and then here again we pop up. At 2 we pop up, and then we head off toward infinity. So just on the x-axis, our number line graph is there in red. And now it says, where is y less than 6? So again, use the trace feature, x-coordinate lower left, y-coordinate lower right. And what we're looking for here is, maybe right about here. Imagine, there's a dotted line here. We're trying to find where does this function exist below 6. So we use the trace feature. And I'll give myself a little bullseye here. This will be blinking. And, we're moving it along here. We're looking for less than 6. So that's all of this. We're under 6, we're under 6, we're under 6. Up, 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 up. Right here is where we cross out. So your y-coordinate will be just a little over 6. And what x-coordinate is going on when that happens? You look down, that'll be right at about 4. So for this one, I'll do this in blue. Where is it less than or equal to 6? I'll put a bracket here at 4. And then everything to the left, because never again is our function above this dotted line up here at y equals 6. All right, there we go. Calculators, those T89s are great things. Homework for this section. No, we got another one here. I think we've had about enough fun, and actually, this one is not in my notes. So let's not worry about this. We've had enough, and as far as homework, because this is a lot of calculator stuff, no homework. So enjoy.